All right, this video is going to attempt to answer this really good and important question of why does in Vertex form, why we have this negative h right here? We can just say it happens, but why the heck does that happen? In this example, for example, if you've been looking at it, if I'm looking at x plus 4 squared plus 2, following this formula would tell us that the vertex happens at negative 4 and positive 2, where the 2 comes from this point right here, this k, and this negative 4 is always the opposite of this coefficient right here. Why does that happen? Well, first and foremost, let's look at Desmos here, this graph of this function, and we can easily verify that that is the vertex, so just get that out of the way. This point right here, at negative 4, we get an output of 2. That's the smallest or the minimum value of this graph. By the way, we know the vertex for this one is a minimum because this is an upward facing parabola because of the lead coefficient here in front of the x plus 4 squared part is a positive 1. We don't see the 1 there, but if it was negative, this thing would be facing downwards. In fact, I'll just show you what that looks like real fast. I'll put a negative 1 there. This thing just flips over. Okay, so at least we verified that this formula is not incorrect. If we type it in this way, we'll get this vertex point at a negative 4 comma 2. The question is, why the heck is that happening? Well, first of all, look at this table. We see that at negative 4 we get this smallest point out at 2, and every point out around it is bigger. And let's kind of do some investigation by plugging in some numbers. First of all, if I plug in negative 4 to this function, what happens? Pay attention to what's going on with this part of the function right here, this x plus 4 squared part. When I plug in a negative 4, what I get is negative 4 plus 4 squared plus 2. That would be negative 4 plus 4 is 0, 0 squared is 0, so this just outputs a 2. Importantly, the result of this part becomes 0. This is adding nothing to the value of 2. Let's plug in something like a negative 6. If we look at our table here on the right, we should get out a 6 from this, and let's just verify that. If I plug in a negative 6 here, negative 6 plus 4 squared plus 2. This gives me a negative 6 plus 4 would be a negative 2. If you square negative 2, you get 4. So the result of this is a positive 4. In fact, anytime we do some math here and square it, we're always going to get a positive number. That's actually the key to this whole conversation. Plus 2 equals 6. In fact, if we plug in any number into this spot right here of this x spot, that's not negative 4. If it's negative 6, negative 5, negative 10, positive 30, whatever we plug in, after we square it in every case, we will be adding something to this 2 right here. In this case with a negative 6, we got negative 2 squared, which added a 4. Therefore, the smallest value this function could output is the x value that when you plug it in, it zeroes out this part of the function. It would not be adding anything to the 2 right there. So when you look at this, when you look at this original function, one way of thinking about that is, well, what x value do I plug in here to make this thing 0? And the answer always is, it's the opposite of whatever you're adding on here. Let's look at another example to try to clarify this. Let's investigate this function right here. We have f of x equals negative x minus 3 squared plus 1. Again, in the same way, I've put that into the graph here. We can verify that the vertex of this parabola is at 3, 1. Now again, why is that the case? Well, first of all, vertex form would tell us that this x value is the opposite of this, but what's happening in this case is we're plugging in a 3 for the same reason as the previous example, because 3 minus 3 zeroes out this part right here, and we still get out this 1 then as a max value. Again, I'll just show that here. If I plug in a 3 into this function, what I get out is this 3 minus 3 squared plus 1, which gives us 0 squared, so minus 0, which does nothing, and we just get output a 1. And excuse me here, this was plugging in 3 into the function. That's that vertex point. Let's plug in something now like 5. If I plug in 5 to this, what I'll get is negative 5 minus 3 squared plus 1. Now the result of this is 5 minus 3 is 2. 2 squared is 4. So I get a 4 from this part, but this negative would make this minus 4 plus 1, which outputs in a negative 3. In this case, whatever happens after the squaring, because of this negative outside, will actually be subtracting from this function. So the largest value I can get out from this function would be a positive 1 when I plug in a 3 right here. That's the biggest possible. Anything else I plug in for x will make me subtract something away from the 1. Again, if you look at this, putting a 5 here, 5 minus 3 squared is 4, but this negative is not affected by that squaring action and stays here and will end up subtracting 4 from that value of 1 over here. And you can see that played out here on the graph, is that the highest value output here is a value of 1, which occurs when I plug in a 3 because that zeroes out this first major term right here. Anything else I plug in, from a 1 to a 5 to a 6 or anything else we want, let's plug in a 10 just for fun, we would get out an insanely large negative number. Again, when I plug in 10, it's the action of what happens here. So that would be, by the way, if I think about 10, I could plug in 10 to this. I would get 10 minus 3 is 7. 7 squared is 49. I'd be taking away 49 from 1. That's where I get this negative 48 from right here. So to summarize, the way to think about vertex form, let's look at just a couple other little examples here on the fly and to say how to think about finding the vertex. So that's the why, but then let's just think about like an action. How do we do this quickly and not confuse ourselves? Well, if someone gives us something like this, we have x equals, let's say, x minus 7 squared plus 15. Well, the vertex is going to occur at the x value we plug in here that makes this term 0. That would be a 7. And the output when we plug in a 7 to this will be a 15. And again, we just output this part because we've zeroed out this part right here. I know, without even looking at the graph, that this would be a minimum value. This is the smallest thing output by the function. So if I plugged in any other x value in here, I would actually get something positive out from this term that would add to the 15. For instance, just for fun, if I plug in an 8 into this, I'd get 8 minus 7 would be a 1. 1 squared would be a 1, would output a 16 right here. I did that quickly, I know, but you could verify that. Anything else will output something bigger because it will be adding something to the 15. In terms of this function, I am thinking what value do I plug in here to zero out this thing right here. In this case, that would be a negative 6. And the output when I did plug in a negative 6, this would end up just being this number of 12 right here. This, in this case, would be the maximum output value. In fact, 12 is the maximum output value by this function. So I've plugged in anything outside of negative 6. If I don't zero out this part of the quadratic, this will end up subtracting something away from the 12. And I'll just end on this visual now on the right. I've redone this graph so that it reflects this function right here. How we analyze this stuff always is, first of all, is this positive or negative? If it's negative, it means our parabola is concave down like this, which means our vertex point at the very tip of this would be a maximum value. It's the largest value output. That largest value comes from this term right here. It's this value, Why is that the maximum output value? It's because we're plugging in something that doesn't subtract anything from that 12. And we find that x value by figuring out what gets plugged in here to zero out that term.